Click next. Example 1. Okay, click empty, click finish. First, I will increase the font size, go for preferences, click general, appearance, colors and fonts, C++, editor window. Okay, I just increase the font size, click apply and close. Okay. So let me copy the program like what we have done yesterday. So this is the code which we have done yesterday. Right click, go for debug as, let me set the environment. Click apply and click OK. Switch. I just run this code. Okay, so this is the code which we have written yesterday. Like, let us. Okay. So I'm going to modify this code. Let me terminate this program. I'll show you the effect of bitwise shift operations. So let me declare this port as, okay, I'll give 0, 1, okay, and I just introduce a delay of so this is left shift 1. Okay, so just copy this delay. This is for again for 1. Copy this, I paste this. So this is for 2, okay, and 3. Okay, so right click, build the project. And you check for debuggers, go for debuggers, debug configurations, click debug. Okay. And so this is bitwise So this will shift one time. Okay, so let me keep a breakpoint here and just keep a breakpoint at this 22. Okay, line number 22, and click resume button. So currently you could see this 1 bit. Okay, so this is the first bit. Okay, so when I execute step-by-step execution, okay, when I execute step-by-step execution, it shifts one time and shifts one time. Okay, now it shifts 2 times and now it shifts 3 times. Okay. So this is how bit shift works. So you could also do the same thing for 128. So 128. So you need to calculate 100. So decimal of 128, hex value is 80. Okay, so make this as 80 and make this right shift. Okay, now let me show you the right click, terminate, and build the project again. And debug as okay. Switch. So if you check, if you click resume button now, okay, so I just go step-by-step execution. Okay, and 2 shift, and this is 3 shift. Okay, so this is for bitwise shift operations. You know how bitwise shift operations work. Okay, so I have 8 LED here. Okay, let me put a for loop. So I will put a for loop here. U32 underscore T of I equals 0. Okay, I less than or equal to 7 I plus plus. Terminate the program now, right click, build the project, and debug as. Okay. So if you check this output now, switch, I just remove the breakpoints. Okay, click breakpoints and I disable all the breakpoints and click resume. So you could see that the LED is scrolling now. Okay, so now let us see an example for how to extract bit. So bitwise shift operations, like what you want to learn is you can shift the bit left or right by using this symbol, and this is the bit, how much bit you want to shift. Like if you give 1, it will shift for 1 bit. If you give 2, it will right shift this value for 2 bit. Okay, and so 3, it will right shift the value for 3 bits. Okay, So now let us see an example of how to extract this bit. Okay, for example, I have a data like this BC10. So the binary value for BC10 is 1011 1100 0001 and 0000. Okay, so this is the binary value and data to be extracted. So we need to extract from we need to extract the data from 9th to 14th bit. Okay, we have to extract from 9th to 14th. So this is 0 1 2 3. Okay, so from here to here we need to extract the data from 9th to, so this is the 0th bit, 0 1 2 3 4 5 6 7 8 9. So it starts from here, from 9th to 14th bit we need to extract this data. We need to extract this data here. So the binary value of so we need to find out, we need to extract the data. Okay, so we need to extract this data. In order to get this data to this point, we need to shift this data. We need to shift this data by 9. When you shift this data by 9, like this value will go for here. This 9th bit will go for this location. Okay, and after getting this location, after getting this shift, then you can use the mask data to get this value. Okay, for the mask data is remaining the bit which you want, and the rest of the bit should be 0. When you button with this operation, you will get the you'll get only this data. So this is the output data. Okay, so this is the extraction. Let us check on the program. Okay, so I just stop this program. I just create a file new. So I'll create an STM32 project. Okay. So what I will do is right click, I'll go for properties. I'll exclude this file. Okay, and I copy this program. Okay, so let me modify the file here. Okay, so okay, so first thing is to declare the data here. Okay, so the data is uint 16 underscore t of data equals 0x BC10. Okay, and extracted bit I'm going to store it on uint 8 underscore t. So this is the extracted bits. Okay, so we need to extract from 9th. So from here to like 9th to so let us check the binary value for BC10. Okay, the binary value for BC10. Okay, so this is the one 1011 1011 and 1100. Okay, so this is the binary value. So data to be extracted is this. Okay, so from 9th bit to 14th bit. have to extract this data. Okay, extracted bits. So now so extracted bits equals, you shift this, right shift this data to 9. Okay, and mask with this 3f. So the mask value is 3f. Okay, mask with 3f. Okay, so right click, build this project now. So run as debug configurations. Click debug. So the extracted output value should be 3f. Sorry, 1e. Okay, 1e. Let us check. Let us run this program, and let us go for the variables and check for the extracted bits. So let me relaunch this program. I will keep a breakpoint here. Okay, and I will relaunch this program. So let me put a right click, build this project, run as debug configurations. Let me set the debug configuration. Switch. Okay, let me put a breakpoint here. So remove this breakpoint. Let us resume the program. Okay, so if you check now, the value is 30. Okay, so right click, just change the format to hex. It is 1e. Okay, if you check the format for the binary format, so this is the extracted bits. Okay, so this is the output data which we need. So and this is the extracted bits. So this is how you extract the bit from the packet. Okay, when you have a 16-bit data or 32-bit data, so you could extract the bit. Okay, now let's go for the next program. So I just create file new C project, C manage build. Okay. Okay. So click next. Choose MinGW GCC. Okay. And this is example3. Click finish. Click finish. So file, go for file new, add a source file, main.c. Okay, main.c. So in this program, like what we are going to do is we are going to read the data. Okay, we are going to read the data, and we are going to create a structure, and in this structure we are going to store the packet in this format, like CRC format. CRC is 2 bits, and status is 1 bit, and payload is 12 bits, and bat is 3 bits, and sensor is 3 bits, and long address is 8 bits, and short address is 8 bits. Okay, and mode, address mode is 1 bit. So we are going to store the data in this format. So we are going to decode the 32-bit packet information, and we are going to store it on the structure. Okay, and then later we will convert this to bit field. So to create this, like, you have to so just copy the okay. Now let's create a struct of packet. Okay, so uint 8_t of CRC, and let me copy this. So this is same as like here, status payload BAT. Okay, so this is status, and this is payload, and this is battery, and this is okay, sensor, and long address and short address and address mode. Okay, this is long address, and here it is short address and address mode. Okay, address mode. So payload is 12 bits here, so it should be 16T. Okay, so the rest is okay. Now let's let us get the packet data. It's a 32-bit size. So the packet data. Okay, so printf of enter the packet data. Okay, enter the packet data. Okay, so flush of std out and scanf %x ampersand of packet data. Okay, now let us declare the struct of packet frame. Okay, now frame dot crc. Okay, so before this, let us frame dot crc. So let us copy this frame dot status, its payload. Okay, address mode. Okay, so now before that, let us print this one. Printf of CRC. Okay, %x /n comma this frame.csv. Okay. So I'll copy the status, copy the payload, copy the bat, sensor, copy the sensor. Okay, I'm just copying this variable long address, short address, and address mode. Okay. So same thing like status, frame.status, payload. Okay. So now we need to store the data. Okay. After getting the data from the scanf, like we need to store here. So equals now to get the packet data. Okay. To get this 2 bits, last 2 bits, the mask value is 3. Okay. So packet data. Okay. And the mask value is 3 to get the last 3 bits. Okay. So you need to do the casting of unit 8 of t. Okay. So just copy this. Okay. For status it is 1 bit. So for status, like it is 2 bits. Okay. It is the CRC is 2 bits. So we masked the data and we extracted this 2 bits. Now to extract this bit, you have to shift this by 2 bits. Okay, you have to shift this position by 2 bits and mask the value by 1 bit. Okay, so it will be like this, like shift by 2 and mask value is 1. Okay. Now for 3, okay, to get this 12 bits, to get the 12 bits, you shift this by 3 bits, okay, because this is 3. You right shift this, so it will come here and then 12 bits. Okay, you need 12 bits. So 12 bits, like if you check the mask value for 12 bits, okay, 8, right, 12 bits. So this is the mask value. F is the mask value. Okay, F is the mask value. So you shift it by 3 and the mask value is FF. Okay, mask value is FF. It's more than 8, so 16. So 3, 2, 1. Okay, 3, 2, 1. So if for this, okay, for getting this bat is 3 bits. Okay, you need to shift 12 plus 3, 15. Right shift by 15. Here the right shift by 15. Okay, right shift by 15 and this is 7. Okay, and for this 15, for this you have to include this 3, 18. So you need to include the bracket. Okay, For everything you need to include a bracket here, so that it will give priority for this first. Whenever you use these operations, you just include the bracket. So for this it's 21. Okay, if you check this, you have to shift 3, 15, 18, 21 to get the long address, and it is 8. 8 is FF. Okay, 8 is FF. Here the mask value is 7. 7, and for this you need to include the bracket. Okay, and shift this by 29. And mask value is 3. Okay, shift this by 29. Okay, so for this it is 12, 15, 29, 30, 31. Okay, 31, you have to shift this by 31. Here it should be 31. Okay, it's 1 bit. It is address mode is 1 bit, so the mask value is 1. Okay, so we have completed this one. Right click, go for build project, and let us check. Click run as local C++ application. Okay, so I give f of 1 2 f of 1 2 3 4. Okay, so these are the values which is extracted. So let us check whether it is correct. I take this calculator and make this hex value. Okay, so this is the value. The first is 0. CRC is 0. Okay, the last two, the CRC is 2 bits. CRC is 2 bits. The status bit is 1 bit. Okay, the status bit is 1 bit. The 1 is extracted. After that, 246. 246, if you convert this to binary, you will get this one. Okay, so the bit has been extracted and it has displayed here. Now let us check for the size. Okay, let us check the size of this printf. So we have extracted size of struct is size of frame. Okay, I click build this project, run as f of 1 2 3 4. Okay, the size of the struct is 10 bytes. Okay, the size of the struct is 10 bytes. Whereas it is only a 32-bit data. Okay, it is only a 32 bits. It's a 32 bits data, but it is showing the size is 10 bytes. Right, it should be 4 bytes. So in order to save this information, in order to store only the 4 bits, okay, you can use a concept called bit field. Bit field. So let me save this output. So this is the output which we get. Okay, I'll copy this output. I open the paint and let me save this program. Okay, now let us check for the bit field. Right click, I paste it here. Right click, go for properties, and I will exclude this build. Okay, I'll exclude this build, and just click here. So now you need to configure, like I'm going to configure this as here you have to choose the right data type, 32T. Here you have to mention this is only 2 bits. Okay, so first I'll copy this, and for a status is 1 bit. It's 1 bit, so you have to check all this. It's 12338. It is 12 bits. It is 12 bits, so it will allocate only 12 bits. Okay, and this is 3 bits, and this is 3 bits, and this is 8 bits, and this is 2 bits, and this is 1 bit. Okay, so right click, build the project. So if I write, if run as local C++ application, so I'll enter this FF1234. Okay, the size of the struct is 4 bits, 4 bytes. Okay, so we have saved the, if you check, like we have saved this one. Okay, we have the size of struct is 4 when you use bit field, whereas when you use struct, it's the size of struct is 10. Okay, so